Hi, my name is Nick Owenby. I'm 15. I enjoy bike riding, chemistry, and basketball. And I'm looking for a girl that... Whoops, wrong video. Today I'm going to talk about collision theory, mechanisms, and catalysis. Collision theory. Reactants must collide with each other. They must have sufficient energy or activation energy, and they must be oriented properly. Doing this results in effective collision where a reaction occurs. In the first line of the picture, you can see that reactants are moving too slowly, so they bounce off each other with no reaction. In the second line, the reactions aren't facing the right way, so they bounce off each other because the right parts aren't coming into contact with each other. In the third line, the reactants are energetic and oriented correctly, so they react because they have enough energy and the right parts are coming into contact with each other as a result of an effective collision. Mechanisms. A mechanism is only a guess at the reaction pathway. It can't be proven because we can't tell the steps in between. It's a sequence of elementary steps. A mechanism must have elementary steps that add to the overall reaction, have a rate law that's the same as the experimentally determined rate law, and have a rate determining step that's the slowest step in a reaction from which the rate law can be determined. If you look at the graph above, you can see the first bump has a higher EA than the second bump because it's the slow step where the rate determining step is, so you can determine the rate law from that step. And the intermediate in between is products that are formed in one step and consumed in another. Fast equilibrium may occur before the rate determining step, and the rate law must be adjusted for this. This makes some reactions more likely to occur, such as termolecular reactions. For example, two NO molecules may combine to form N2O2 in order to react with an H2 molecule, which it would not likely do otherwise in a termolecular reaction. Intermediates are species made in one step and consumed in another step, as I showed on the last slide. And molecularity shows how many species are reacting. A unimolecular reaction is where one species dissociates. A bimolecular reaction is where two species collide. And a termolecular reaction, which is very unlikely, is where three species collide at once, properly oriented and with enough energy. In the bottom right picture, you can see that three helium atoms are coming together in a termolecular reaction, which is very unlikely. Catalysis. This provides an alternate reaction pathway with lower activation energies. Homogeneous catalysts are the same phase as reactants, so if you have a solid reactants, then you'll have solid catalyst. Heterogeneous catalysts are a different phase, so if you have solid reactants again, then you'll have a liquid catalyst instead. And it's not shown in the reactant mechanism because it's not consumed in the reaction. On the right, you can see a graph where the purple line is a catalyzed reaction and the red line is an uncatalyzed reaction. And the purple line has lower activation energy and it takes a different pathway, but it comes from the same reactants and reaches the same products as the other pathway. Kinetic control. Kinetic control is a reaction pathway with lower activation energy, but less stable products are formed. Some products may be formed by kinetic control at the same time as others are formed by thermodynamic control. So some of your products may be thermodynamic controlled and some of them may be kinetically controlled. The green line is kinetic control products, which have lower activation energy than the blue line, which is thermodynamic control reactants and products. But the green line forms less stable products than the blue line does. And here's a problem. The reaction between NO and H2 is believed to occur in the following three-step process. NO plus NO equilibrates to N2O2, which is fast. N2O2 plus H2 produces N2O plus H2O, which is slow. N2O plus H2 forms N2 plus H2O, which is fast. A. Write a balanced reaction for the overall reaction. On the right, 2NO plus 2H2 forms N2 plus 2H2O. And this is because you just add all the steps together and you find this. Identify the intermediates in the reaction. Explain your reasoning. N2O2 and H2O are the intermediates because they're made in one step and consumed in another. Identify the molecularity of each step. All the steps are bimolecular because two reactants are combining in the reaction. From the mechanism above, a student correctly deduces that the rate law for the reaction is rate equals K concentration of NO squared concentration of H2. The student then concludes that 1. The reaction is third order, and 2. The mechanism involves the simultaneous collision of two NO molecules in an H2 molecule. Are conclusions 1 and 2 correct? Explain. 1 is correct because the overall reaction is found by adding up the orders of the reactants, which adds up to 3. 2 is not correct because the mechanism involves two NO molecules combined to form N2O2, then colliding with H2. Explain what effect a catalyst would have on a graph of the reaction pathway. A catalyst would make the reaction take a different pathway and lower the activation edge. Alright, thanks for listening.